today's video, we're going to be creating a demo of one of the Anagolay workflows that creates a content address of a directory or a file. Adriano is a core developer of the Anagolay team, and he is in charge of the workflows and their development. So, Adriano, what are we going to do today?
Hi. So, for today's presentation, we want to have a command line application that, given as argument a folder or a file, will return the content identifier of all the files inside the given folder, and make also a content identifier out of all the content identifiers from all the files. It's considered this like a checksum, cryptographic hash, analog to SHA or other similar algorithms.
So basically, after this demo, we can use this binary to make assurance without uploading to IPFS that there is a hash of the file.
Right. So, for instance, in this demo project, we have a couple of images, and there is already a built release demo. So let's just run it. This is what we expect. We have the hash of the single files plus the hash of the two CIDs that were computed, and this can be considered the directory CID. So this is what we want to accomplish. In order to do this, we are using a workflow, an Anagolay workflow, that out of some byte computes indeed this CID. So let's start. I'm going to create a new folder, call it first demo. And I'm going to init here a new cargo project. Now, in order to navigate recursively through the target folder, I'm going to use this library called blob. The latest version is 0.3.0, and let's also by default disable the default features. Now that I have this, I can edit my main and pass the input arguments as a vector of strings that come from the environment. Let's collect them into a vector. Now, I would like to write a match on argument length, so that if I pass no argument, meaning only one argument, which is the program name, let me import this glob library, and also the first analyzer seems not to be working out of the box. But so what we want to do here is this is a Unix style pattern we get from the current working directory, all the inside directories, and we get recursively all the files inside that. This is the meaning of this pattern. On all other cases, we want to, so we have as argument 1 the path of the folder we want to target. So let's call it path and get it as a std path buffer from our arguments. The second one.
It does work last time. I guess it picked it up.
That should be fine, right?
Yeah, I guess so. Yeah.
Okay. So I use this because it's easier to, for instance, check if path is a directory, and if it is indeed, we can push the same glob pattern, which is this, and this allows for the target directory to recurse into all the contained files. And then again we use glob to return on this path, and so the return type of this match would be our, let's call them globs, which is an option. Yes, right. So I want to, yeah, this would probably have just let me do it here. So what's the problem here? It wants a string, so we get two strings unwrapped, and then here this is a result, so we unwrap both of them. So we have paths. That's okay. Yeah, it's just I feel like the analyzer is giving some issue. Okay, I need to import the end.
The end is not important.
Yeah. And then here, he wants glob. I don't understand. Okay, this is fine. It was just that. I forgot. Okay, so, what else? So we have a result of paths now. So let's filter this, and we want to filter for, let's just keep the files which are accessible, so which have an okay result, and which are indeed files. So we don't have folders or non-readable files. Like this should be fine. We should have globs, which is just paths of files right now. Okay, so let's move on to compute our CIDs. So let's make, yes.
And this is all just preparation. So this is all just gathering the data?
Yeah, this is passing the arguments and preparing the work. So now let's get into it. I'm concatenating all the CIDs from the files into a new string, and I will then compute the CID of that string, and this will be our final result. So in order to do so, we iterate through these globs. Okay, so we get file name out of each of them, same as before, entry to string and that. So what I want to do now is get the bytes out of this file and pass them to the workflow. So let's get the byte beforehand. I use the std fs read function, which makes it simple. Bytes will be read file name, and we can just unwrap all of these. We are not doing much error checking here. So now about the workflow, I need to import it as a dependency. The workflow has a specific name. It's called WF CIDV1 from array, and we can use it directly from its Git repository on Anagolay IPFS. This is it. And again, we will disable the default features. Would be all. We can also enable the STD feature for now, since we are using STD anyway. Okay, now we have the appropriate dependency, we can use it. So our flow, it's a computer program that accepts some inputs and return an output.
Maybe you should fix the cargo check fail.
Oh, right. The fact is, yes, we have this problem with Git from getting the sources directly, dependencies directly from Git. It requires a specific configuration of cargo. So in order to solve it, I make a .cargo folder inside the project that contains a config DOM file. And in this file, I just need to report this. So net git git fetch with CLI, and this must be true. So now it should be capable of reading and compiling the workflow from Anagolay IPFS. Let's get back to our code. So let me define some inputs. The inputs consist in a vector of reference counted dynamic any. This it's a multiple type, unknown type. Every workflow gets different input and retrieves different outputs. So this interface gives us the most flexibility. We just pass a reference to whatever we want and get a reference to our result. That way we need afterward to downcast. I will show it.
That's a reference to a specific member, right? Memory pointer.
Yes, meaning that we don't copy inputs from to pass them to the workflow in order to preserve performance. We are creating references to local memory, so this is more performant.
Yeah, because the workflow CID can be used to calculate gigabytes of data. It will be cloning that gigabytes of data, and knowing that the Rust is all very secure when it comes to this kind of stuff, that there is no garbage collector. This gives a performance, right?
Yeah, so this LC is a smart pointer, so it's a reference count on this data. It means that the reference to these bytes will be counted, and it will be considerable no longer rounded as soon as nobody is referencing to it anymore. So this is the way for us to deal with references and without using a garbage collector. So yes, this is the way to pass a reference to some data which can be propagated also outside of the scope of this block code.
Right. Yes.
Okay, so let's now call the workflow. I will make a function for this called WF, and I'll just pass the input. So for our call WF, getting inputs as a vector of LC dynamic any, and returning, we can say it will return a string, so that we avoid the repeated parsing with just doing inside this function. Let me now instantiate the workflow on the dependency. So I call it with a fully qualified path. There is two classes inside this package. So we can see that there is only one segment, but there may be more of them. And we know that we just invoke next one time to get the final result. So we have our result.
That's because you have only one segment, right?
Yes, exactly. Else we would need to invoke next several times until we complete the workflow and passing the appropriate input for that specific segment. And I speak about input coming from outside, either user input or input which is not already available to the workflow, because internally in its state, the input coming from already computed segment is handled automatically. So here, for our first and only segment, we're passing as the external input our vector that contains a single input, which is the bytes of our file. And as a result, we expect a segment result that contains the string CID of the file. So let's get this. First thing, I get the result locally as a reference. Okay. And this allows me to perform different operation on this. We want a string, so we can get the result get output, and this must be interpreted from a string because again, it's an RC dynamic any string as well, but we know that we want a string, so we unwrap the output. First, unwrap because it's an option. If it was not the last segment, the get output would be none. But since it is the last segment, get output is sum. But this sum is a RC, so we can downcast the reference and tell to the compiler that it is a string. And then we need to unwrap this operation as well. And finally, we get a nouned version of this string to a clone. So, okay, this output now is getting the CID directly from the workflow. And what I need to do now is, for instance, write something like the file name, and it's okay. So maybe let's test this. What's happening here is that inside the workflow, at a certain moment, so we can see it's inside the workflow. This is the generated code of the workflow. We get from a byte input, we go through 3 operations. So first one, it's the op multi-hash, and then it's the op CID, so 2 operations actually. But we have a problem here. It's expecting a multi-hash wrapper, and it's receiving another multi-hash wrapper. The reason for this, it's simple. In the moment Rust compiles, it's finding 2 times the same crate, and the problem is one comes from the IPFS, and one it's coming from Git. So we need to patch these 2 in order to have only one of them. And we can add a patch here for this URL. And it should use instead the same operation as in the workflow. This one. Let's try again. I forgot some quotes. What's wrong with this? Forgot to say. Okay, so we have several imports missing. The LC, the core any as well. So we have some problem here. So this.
So what does it say? Expected enum option found in a result. Maybe small OK, like small case OK.
Right.
That's the one.
Okay.
And now the get output is for the result. Are you sure it's get output on that? So result.
But it expects a result.
You're not unwrapping are you unwrapping the result?
Yeah, it's an option. Now it's okay.
Yeah. Rust language. What can you say?
Okay, so yeah, I forgot that thing to push into our CIDs. I need to push to append the output. That's it.
It's a reference, yeah.
Okay. And well, let's try to see if it works. Okay, this works. So last thing I need to do is call the same workflow again. So let me get ownership of this thing. And then this time our input will be the byte of this string. And lastly, our output, it's again the call WF function given its input. And yeah, so we can just print the CID directory. CID is this output here. Okay. So this will run in the current directory. So let's try the asset to pass asset as parameter, as argument.
Nice.
Alright. There's something strange because, it's probably not resolving the assets in the right place. Maybe it's this. Oh, now it's good. And we have this unused input, but okay. That's not a
because
problem.
You use the fully qualified.
Yes. So this is it.
Okay, cool. Can this be made asynchronous?
Yes, indeed. Right now we're using the synchronous version, but we can use the async feature to convert this to fully asynchronous. So we will need to await the next operation. And of course, this call is now asynchronous along with this one. And this means that the call WF is now to be awaited. And we need to use a runtime which supports async. So let me use Tokyo version 1. And I will use the full feature so that I can write on top of main the annotation for the Tokyo main. That's it. So this should now run asynchronously.
So what are the benefits of asynchronous execution?
Well, you imagine this is also compiled to WASM. So having the possibility to perform non-blocking operation from JavaScript may be useful in case this is a user interface, so it does not block. You can also imagine capability to run this in parallel. For instance, this cycle could be run in parallel. So there are several possibilities. Let me just fix this. We have to await after the unlock. Isn't it?
No, it's next should await before, no? So what does it say? Inputs.
It's not a filter. Let me clean. It should be a filter.
Let's try again. That indeed looks cool. Maybe the STD that you have in a cargo toml for the workflow, it shouldn't be there.
Okay, so this is it with the corrected features and working asynchronously. Maybe last thing, we can also get out of the result the time of execution, get total time out of this, and it's an unsigned integer that we can then output as indication of the performance.
And what is the performance? That's how is it measured?
It's a millisecond.
And that's in milliseconds, that is spend time inside.
Exactly. Yeah.
Okay. So that cannot work in, let's say, nostd environment.
Well, no, because it requires some measuring of the slew clock or some other way to determine how much time passed. So this will always return 0 in nostd. Right now it returns 0 also in std because it's very fast. But you see, if I use it in the current directory,
still
which is still quite fast, but I've seen some 3 milliseconds around. Not sure. Yeah, it seems indeed quite fast. So but it should otherwise return more than 0 for bigger files. Well, I think that's all.
Cool. That is excellent. Oh, one more thing when you were talking about the nostd. Since Anagolay is built on Substrate and this is written in Rust, Substrate is written in Rust, can this be run like inside Anagolay in the runtime? And can it be compiled to the WASM?
Sure.
Like, let's say 4+ upgrades. Similar.
Yes, we are running this exact workflow. We're running it on chain to compute our CIDs on chain. So you see, I had to add the STD feature so that the performance was was used because this nostd is typically used on chain, and on chain we don't have the STD library, so it's still very useful to compute CIDs, but we don't have all the features. So yeah, in order to have the performance analysis, we need the STD features as well.
Cool. That sounds really cool. And yeah, 70 milliseconds, and that I believe that big one is around 30 megabytes. So that's a 70 milliseconds on unoptimized, binary. You're missing L.
Yeah.
L8, yeah, or 8 here. 29 megabytes. Just for fun of it, because we have still a little bit of time. Can we do a build of release of the release and see how long it's going to take to calculate the CID for that specific target? While we are waiting, the next video in the session is going to be about the same workflow implemented in the Node.js, and the next one is going to be implemented in a UI as a worker and an automated thread with the Svelte kit. So stay tuned, and we're going to try to introduce you with all the technology that we are building in Anagolay. Show you how we can use workflows, operations, what they are, and how deterministic behavior of such code can help us to build some more stable systems that can last longer without any breaking. Talking about that, the URL that you see here on line 14 is the rehosted bare Git repository, which means that we are generating the code, and we are out of the operations, which are the core parts of the workflow, and storing that repository onto the IPFS. We don't even have this in our GitLab. It is a completely hosted as a bare repository with a single commit on the IPFS. Oh yeah, that's a massive improvement.
Way faster.
Oh well, that something has happened. There was a 70 milliseconds before.
Maybe the cargo run is even less optimized. No, it's
not. Well, it's still fast, and we are talking about the 30 megabytes on file optimization. So you can imagine that you can write these kind of programs in Rust, compile them into the binaries, ship them on your CIs, and there is potentially microservices for any kind of checksums of any kind of files, regardless how big they are. So 29 megabytes is calculated in 16 milliseconds on a shared Git pod environment. So we don't even know how many people are actually using this environment. Thank you, Adriano. This worked. And stay tuned for some other cool videos that are generally going to be about Rust, Anagolay, Workflows, operations, and Node.js.
I'll see you soon. Ciao.